Acha, Argand diagram. Now, what happens in this case? Like, uh, suppose you have a complex number z, which is 3 plus 4 iota. Now, this 3 plus 4 iota, this can be represented on a grid. Like, if you people remember your coordinate geometry, like you have a number which is a point which is 3 comma 4. Okay, so you call this a point 3 comma 4. In this diagram you have, this is your x-axis and this is your y-axis. Now in the Argand diagram, you have a grid like the grid showing the x-axis, y-axis. But there is a very interesting thing in this grid, that its horizontal axis will be showing, this is called the real axis, okay? And this one is called the imaginary axis, okay? Now, when you have this complex number z, which is 3 plus 4 iota, so this is going to be 1, 2, 3 over here. This is 1, 2, 3, 4 over here. So this would be marked over here as a point A or B or C, whatever you want. So this is the point A is representing the complex number z. Now, suppose you have a complex number u, which is 2 minus 3 iota. Okay, so this is 2, and then this is 1, 2, and this is minus 3. So that would be, let's say we call this the point B. So the point B is representing the complex number u. Okay. Now suppose you have a complex number w, which is just 5. Okay. So let's say this is your 5 over here. So let's say we are going to represent this with the point C. Okay. Then you can have, let's say there is a complex number v, which is just that is minus 4 and plus iota. So this is 1, 2, 3, 4. This is minus 4 and this is 1 here. So here is, let me represent this with the point D. So point D is representing the complex number V. Okay, so these are all different complex numbers. Okay, and these are represented by the different points over here. Achha. Now this is exactly like the coordinate geometry, like you can even join them. For example, you have a shape like this and then you have a shape. If you join them, like you see this and then you have this. Okay. Now, there can be questions related to the finding different distances, finding the areas, and like the concept of symmetry over here can be tested, as it was all done in your coordinate geometry. Okay, so uh, other than all the things that you do in coordinate geometry, except writing the equation of a line, uh, you have to remember two things over here. Now, uh, one thing is the uh, that is called the uh, what do we call that? One is the argument. The second thing, and the first thing is the modulus. Now, these are the two terms that you should remember, and you must know how to find the modulus and argument of a complex number. Now, suppose you have, here is your imaginary axis, here is your real axis, okay? And now, suppose this z is here, which is 3 plus 4 iota. So this is 1, 2, 3. So this is 3 here, 1, 2, 3, 4. This is 4 here, okay? So this is going to be, here is, let me call this point A. Point A is representing the complex number z. Okay, if I join this with the origin over here, so uh, let me call this O over here. The length of this OA is called the modulus of Z. Okay, this is absolutely the same as uh, that you were finding that distance through the distance formula. Okay, so the modulus of Z, if this point is 3 comma 4, now imagine you have a point 0 0 and a 0.34. So how would you find the distance between these 2 points? So if you just recall that thing, like, this length is 4, this length is 3. So this is going to be the square root of 3 square plus 4 square. Okay. So for the modulus, please remember for the modulus, uh, suppose there is a complex number Z, which is A plus iota B, then the modulus of this Z would be the square root of A square plus B square. Now there is a very common mistake over here, that when people finding this modulus, they include this iota into it. Please don't do that. This is basically the real part square plus the imaginary part square. That is how you find the modulus of Z. Okay. So therefore, if Z is 3 plus 4 iota, then the modulus of Z would be simply 3 square plus 4 square. So that will be 5. Okay. So that is the modulus. Now, let me see if I have some questions here, and you can find the moduli. Um yeah. So here is this third question, guys. You have to try this third question, where you have to find the, try this question. It says find the modulus, and abhi filhal you just find the modulus. I'll tell you the argument in a minute. Okay. So you try finding the modulus of these complex numbers, and you have to be quick. So when you're going to find the modulus of, let's say, uh, this A, you better name it something, like you say this is going to be equal to a complex number W. Okay, and then you can say this is the symbol of, like, you have to put these lines around, like we use for the absolute. So the modulus of W is going to be the square root of 12 square plus 5 square. You must know this by heart, that this is going to be 13. Okay, you find the modulus of 5 iota. So you see that 5 iota, there is no need to use any formula here. So it's 1, 2, 3, 4, 5. So its distance from this origin is already 5. Even if you use, like if you write it as 0 plus 5 iota. So if this is a complex number Z, let's say, so this modulus of Z would be 0 square plus 5 square. So that will be 5. So if your complex number has just one part, for example, there is a complex number Z which is just 4. So what will be the modulus of Z? Bacho? Hmm? Yeah?
4.
That will be 4. Thanks, Scott. Some of you spoke. Okay. Now, suppose there is a complex number which is V, and this is just minus 2 iota. So what would be the modulus of V? Hmm?
2.
Yeah, that will be 2. That's great. Okay. So you only need to apply this formula when there are two of these, both the components are there. Okay. So like if you look at this G part, now suppose this G is equal to, let me call this P. Okay. So the complex number P is under root 5 plus 2 iota. So when you find its modulus, so that is going to be the square root of under root 5 square is 5 plus 4, so that is going to give you 3. Okay. So this is the modulus of this complex number P. Okay. So you people should be now familiar with the term modulus. Okay. Now I take you to the argument thing now. First thing that I told you, that was about the modulus. Okay, how to find the modulus. So that has been derived from the distance formula. So modulus is basically refers to the length between 2 points over here. Okay, and if you take it as vectors, you remember you people had vectors like there is a vector A, which is let's say 3, 4, and then you have to find its magnitude. So that was also like this. This is 3 square plus 4 square. So just like you have the magnitude of a vector, similarly you have the modulus of a complex number. Okay. Now the second thing is the argument. The argument of a complex number is the angle that it makes either anti-clockwise or clockwise from this, like, this real axis, positive real axis. Okay. Now, suppose if your complex number is somewhere over here. Okay. So its modulus would be this angle. Sorry, argument would be this angle. So the argument is taken from like 0 to pi, or it is taken from 0 to minus pi. We don't go beyond pi or minus pi. Okay, there are reasons for that. You will understand this when you will be practicing more on it, and you will be plotting them on the Argand diagram, and then you will yourself realize that why we can go beyond pi and minus pi. Okay, so now let's practice some questions on this argument of the complex numbers. Let me go to the next page. Uh, yeah. Okay. Now suppose there's a complex number z, which is let's say 2 plus 2 iota. Okay. Now when I plot this on this Argand diagrams, this is 1, 2, 1, 2. Let's say here is the point A, which is representing this complex number A. Okay. So can you tell me quickly what is the modulus of this complex number Z? Yeah, that is 4 plus 4. That is under root 8, and that is going to be 2 under root 2. So the next thing you have to learn, that is finding the argument. Let me call this theta. So you see that this length is 2 and this length is 2. Can I say tan theta is going to be 2 over 2? And then this theta is going to be tan inverse of 1. So that will be pi by 4, or you can say this is going to be 45 degrees. Okay, so from here you people need to write down these two formulas, that if your z is a plus b iota b, then the modulus z is the square root of a square plus b square, and the argument of, so we just write it as arg dot z. Argument of z is going to be tan inverse of b over a. You have used this tan inverse of b over a many times. If I make you recall quickly, do you remember when you were onto the in mechanics, onto the when you had resolved the forces and you had to find the direction of the resultant? So there, that direction was like, this was tan inverse of the y component over the x component. Do you remember this or not? And then there was when you're finding the alpha in your P3, when you were writing your, like in this form, r cos theta plus alpha or minus alpha sine. So this alpha was also tan inverse of b over a. So this has been used many times in your syllabus. So that is just going to be a repetition, that the argument of a complex number z is tan inverse of the imaginary part over the real part. And I'm going to repeat this again, that please never include this iota into any of these two formulas. Okay, we just take the real part and the imaginary part. You square them, you add them, and then you find the square root. And here this is tan inverse of this b over a. Okay, so now we go back to the book and try some questions from here, which is yeah, right here. So we have to find the arguments of these complex numbers as well. So we know how to find their moduli. Now the argument of this z, that is the a part. So that would be tan inverse of 5 over minus 12. Okay. Now, when you have to find this argument, this is strongly recommended that you have its Argand diagram in front of you. Now, this is minus 12 here, and this is 5 over here. You see that tan inverse of minus 5 over 12 can mislead you. For example, this could be minus 12 plus 5 iota, or this could be 12 minus 5 iota. And this is one of the reasons that we keep the angle between from 0 to pi and then from 0 to minus pi. Okay. So you, when you have this, like, uh, this mark on the Argand diagram, then you clearly know that this is basically you have to find this angle. And suppose if this was this instead of this, then the Argand diagram would have told you that this is going to be, this is 12, this is minus 5. So you have to tell how much is this angle. Okay. So now let's find, please tell me quickly what is tan inverse of 5 over 12. Don't keep this minus with you. Tell me quickly in your radians, what is tan inverse of 5 over 12? Hurry up. I have to mark your attendance as well. Quickly.
0.395.
0.395. So this argument of z would be pi minus 0.39. This is exactly the same as you were doing in your trigonometry, okay? And in this case, this was, I will be writing 0.395 here, and the argument for this complex number would be minus 0.395, because you people are going clockwise here, okay? So this will be in minus and this will be in plus. Okay, you have to try the third questions parts, okay? I'll inshallah start from the same point in your next class, okay?